have these confidential runtimes on the network that allows us to keep data private in use. We currently have 2 confidential runtimes. One is EVM compatible. The other one is WebAssembly compatible. And confidential runtimes, they are powered by trusted execution environment and allow us to keep data protected while in use. And basically, if you think about the trusted execution environment, you can think about them as basically a black box for computation. Encrypted data and smart contracts go in, encrypted results come out. End to end, it is private and secure. So here is just a quick highlights of the Oasis very robust ecosystem. We launched the Oasis Ecosystem Fund last year. Currently, the size is $235 million. So if you are interested in building interesting applications that are using Oasis Privacy Layer, which is the star of the today, definitely tap into that fund. We're very open to applications. And we also have these amazing partnerships. So besides the privacy, which kind of go hand in hand together. We're also working on responsible AI, and then we have partnership with Meta, formerly known as Facebook. And we also have amazing grants program that is also suitable for developers who are building applications, who maybe just got started and want to explore the confidential runtimes and network or using Oasis Privacy Layer. So I understand quite a lot of people are here today because you're very passionate about Ethereum, and there are probably another thing you guys all have in common is that you're all very passionate about Web3. So at Oasis, we're building the primitives for Web3. So this basically covers 3 major components. First, scalability. As we talked about earlier, Oasis Network is scalable. We separate computation from consensus. We have high TPS. And second is privacy. So we believe privacy is not some sort of bonus or nice to have or some sort of afterthought. This should become a default as for every Solid developers or any blockchain developers out there. What we meant by that is in the current Web 2 world, if you think about it, we transition very smoothly from HTTP to HTTPS. If you open a website, open any URL, if it's started with HTTP, you will probably get some sort of warning alert from the browser telling you you are sure you want to proceed. So HTTPS is basically default here in the current Web 2 world. So we think that's how things are going to be in Web 3 as well. Currently we have smart contract state pretty much all public, but that's not how things should be in the future as we transition from pure public smart contract state to a smart contract state where developers get to configure how they want to make it either fully public or fully private or somewhere in between on that spectrum. And last but not least, the decentralized identity, which is also critical for Web3. So we want to dig into privacy today, which is the highlight of the workshop today. So let's talk about the Oasis Privacy Layer. Again, privacy layer for Web3. So it's powered by Sapphire, which is EVM compatible confidential runtime on the network. So why are we so interested in privacy? Besides what we talk about, this whole migration, kind of smoothly transition from Web 2 to Web 3. We ought to have not necessarily every smart contract contract state needs to be public. So besides that, from a technology perspective, from the use case perspective, why on-chain privacy matters. So let's talk about those pain points. The first, DAOs. I'm sure many of you probably are very much involved, active in some of the DAOs out there. And then, if you think about it, currently the voting process for DAOs, for DAO members, are pretty much public. So that has caveats, the DAO members will not have the freedom of expression, and then that also could potentially, you probably could also have some sort of early voters anchor the late voters that could lead to unbiased voting process. And second, the DIDs, as we know how important decentralized identity is for Web3. So and we know that the data behind a true decentralized identity is more than just some sort of binary KYC data, I pass the KYC, I don't pass the KYC. As we continue to evolve Web3, the data behind the decentralized identity needs to be more complex than KYC, yes or no. So, but the users need to be able to control how they want to share all this data behind their decentralized identity, and be able to do this selective disclosure, because certain data you disclose to some dApp is probably going to be different than some data you disclose to other dApps. For instance, if you're using some sort of lending dApp, sure, maybe in the future you want to disclose your credit score to them, so you can have some sort of under-collateralized lending service or something. But do you want to disclose your credit score when you are doing gaming or something? It's because those are two different categories of dApps, and then it ought to have very different data sets they use, and users get to do this kind of like selective disclosure. And third is in gaming. So I'm sure many of you are playing those strategy games and Fog of War, all these games out there, and then all these game logic currently are off-chain. So off-chain, as we continue to move to Web3, like we ought to have more things move to on-chain, so we can have like stronger integrity guarantees and more transparency. And last but not least, DeFi. I'm sure for those like for those DeFi users, you probably come across issues like front-run sandwich attacks, and those can be resolved by using privacy if we can make specific trading parameters private. So let's talk about Sapphire, the engine behind this confidential EVM runtime. So the first, private variables get to be private, actually private and protected by the trusted execution environments, which is the confidential compute technology we're using for the Oasis network currently. And it's the smart contract get to see the state, and smart contract gets to configure who else can see those state. And when we say it's EVM compatible, we actually meant it. So it's identical user experience, dev experience to Ethereum, and it's also the fees are much lower compared to Ethereum, and also it has those amazing built-in functions like RNG, which is also critical for those games like Fog of War or Strategy, those games. And it also has the general purpose smart contract support, which is some other confidential compute technologies currently might have limitations around. And it's also full composability, which is also critical to Web3 as everyone is building on top of each other. So in short, there's literally no reason not to use it. Right, so the privacy layer for Web3. So this is not just a product for applications building on the Oasis network. This is also a product for applications from any other EVM network out there. So today, the workshop is co-sponsored by Oasis and BNB. So for developers who are building on BNB, you can also use the Oasis privacy layer. The trust execution environment we're using is not just for the native applications on the Oasis network. Any applications on any EVM network can use Oasis privacy layer, just with a little bit of help from the cross-chain bridge. And the assets and users get to stay on the home chains for people who are, want to enjoy the benefits of, user liquidity from BNB chain and don't want to leave BNB chain. That's perfectly fine. We want you to stay where you are, and you could just, deploy confidential smart contracts on Sapphire, and secrets and logic live on Sapphire. But users and assets stay on the home chain, whether that's BNB or Ethereum or any other EVM networks. And the use cases, we have, secret bets we talk about for DAOs, and seal bidding auctions for those NFT minting, and the games, as we talk about those strategy games, and DID, and also private payments. And then for developers, what we really want to emphasize that, it's really, really easy to use, so start integrating in under 15 minutes, and then we really meant by that. And then and from the end user perspective, so if you are operating a DAO or some other sort of categories of dApps on any EVM network out there, your end user don't actually need to know that Sapphire or Oasis network exists. And here is how it works. This is basically a user flow diagram, and we'll explain how that works and what we meant by your assets and users stay on the home chain, and your end user don't even need to know that Sapphire or Oasis network exists. It's purely working from the behind the scene. So here, let's say you have a DAO, let's say operating on the BNB chain, and this is a home network, which is a BNB chain in this scenario, and then you have something you want your DAO members to vote on, a proposal or something. So your user log on to the dApp and want to vote, and they cast the vote and sign the transactions. In the meantime, the gas relayer, which is the key component here, get to convert a little bit of tokens. In this case, could be BNB, could be other tokens on BNB, whatever the tokens that your users have. Convert tiny amount because the gas fees on the Oasis network is also very, very low. So just a tiny amount of tokens that convert that into the gas token required for the Sapphire network, and then sign the messages, and then the ballots, and the voting contract goes into this Sapphire network, and then after voting concludes, the trust execution environment completes the compute. What you have is the ballots as well as the aggregated voting results, sent back to the home chain via the message passing bridge. So in this case, it's just the voting process. You get to keep everything private. After the voting process concludes, you still can make everything transparent. You still can publish, each wallet addresses ballot as well as the end results of this voting. So you get to stay very transparent. By using secret ballot, you still get to be very transparent. You're not hurting, you're not diluting any sort of transparency. As a motto or ethos that you're telling your DAO members about. So this is really just, using secret ballot is really just very beneficial for, very productive governance, where users get to have this kind of freedom of expression, where you don't have, biased voting process. Early voters are now biasing or anchoring the late voters. Cool. So try out Sapphire on mainnet today by scanning this QR code. It will lead you to the docs of Sapphire. I'll probably stay here for 1 second or two for people to scan the QR code. And then there's another QR code. Sorry, we're just like QR code on fire, basically. So this is basically links you to the website of or web page of Oasis Privacy Layer, and where on that web page you get to see what Oasis Privacy Layer is, and also some detailed use case. And last but not least, join the hackathon. We're launching the Privacy for Web3 hackathon very, very soon. So register for the hackathon today by scanning the QR code. Thanks very much. And now we are migrating to the fireside chat with where I'll be the moderator, and the Oasis Tech Lead Nick, and then the DevRel from BNB will joining the fireside chat and talk about privacy and Web3 privacy with the audience. Thanks very much. Oh, yeah. Oh, okay. You scared me.
Check.
Yo.
Hello. It works?
I think it works, yeah.
Hello. Well, thanks for being here. Thanks for having the patience, going through the presentation earlier with us. And here we have the fireside chat between Oasis Tech Lead Nick and DevRel from BNB Chain. First, let's start with a self-intro first. Nick and Dylan, why don't you introduce yourself to the audience?
Cool. Hey everyone, so as you've heard several times now, I'm Nick, I'm the tech lead at Oasis, and I've been building the Oasis Privacy Layer, which allows you to bring confidentiality to your L1 dApps in under 15 minutes. So you heard Linda say, if under 15 minutes, I used to be saying if you don't port your dApp in under 15 minutes, you get your money back, but like maybe someone was actually going to demand their money back, but it's like testnet or something, it's free, but anyway, port your dApp in under 15 minutes or your money back.
Awesome. I'm Dylan, tech evangelist for BNB. I studied and did a lot of research in zero-knowledge proofs with ZK-UTXO, and did my own sets of code audits, and now working on ZK-BNB, which is a privacy, it's a scalability rollup. And we also work on Greenfield, which is a decentralized storage network. And there's a lot of really cool things that we can do with TEE, and I'm excited to talk about it.
Excellent. We're excited as well. So let's dive in. So Nick and Dylan, we're gathered here today to talk about privacy. So in your own opinion, why do you think Web3 privacy matters? In your own words. Like maybe Dylan can start from you, since your experience with ZK as well, BNB, you're working on Greenfield. Like why privacy matters to you and to BNB?
Well, it's privacy it's beyond just being a fundamental right. It's a way where we can protect ourselves if we're decentralizing currency and we're doing this thing with social financing and we're making our own tools. We need to have a level of anonymity, and this ability to really identify one another without actually being able to obfuscate who you are and what you are. Say, for example, if I know you based off of how much money you make, there's a lot of judgment that can get played with into this. I care about it because there might be a disenfranchised community that's living somewhere, and just because I can see what's on their balance sheet or what's inside of their DAO, I might not vote there. I might not want to contribute just because I made this judgment. So I think there's a lot of really important reasons why privacy matters, because it's almost like social policy, and it's a respect. And I think in terms of like digital respect, privacy is necessary in this way. So that's why I care about it.
Excellent. What do you say, Nick?
I think that was a really great overall description of why privacy is necessary. And to that, I only would like to add that privacy is good for when you don't know the full ramifications of what's going to happen, right? So like tomorrow you don't know if something like the government's going to crack down on you, or you're going to go somewhere where it's really important that you have privacy. So it's just so important for everyone to have privacy so that they can be prepared for whatever might happen.
Nice, nice. So yeah, so privacy is obviously critical for Web3 to continue to move forward. So, I mean, this is the ETH event, right? So we can assume most of the audience here are Solid developers. So what kind of private solution actually exists today for Solid developers? Dylan, like what kind of private solution actually exists for BNB developers these days?
Yeah. So in BNB, well, I'm wearing one of them right now. So there's like Polyhedra, where I get to use stealth IDs, which was something that Vitalik proposed. What year?
Last year even.
Yeah, last year I think. And so it was a really fancy way of doing privacy on chain, and then I can put my NFTs inside of this container, and then all the encryption happens, and there we go. Now I have a private NFT, and now I think we're looking for those use cases of where we can apply stealth ID. And then of course we can do, well, since it's EVM, I can do snarks, and I can still run this, and just use the base primitives that are on Ethereum that are available to me in Solidity. So there's that as well. There's other ones, the ones that we were working on with Discrete Labs, which was, we can just have an accountability layer for, using UTXOs, and we can still do, trusted setups or non-trusted setups to run cryptographic proofs. Unfortunately, I think the misinterpretation of what Tornado Cash was originally meant for was, obviously we have to go through the sanction now, and I think there's a lot of really nice and beneficial use cases for hardware applications with running an Ethereum client with Tornado. That could be for the public good rather than for obviously what it's been bastardized for. So privacy is necessary in this way. I think it really comes down to how you as a developer interpret what it's going to do for the public good, build in that way, and then you're good. And then obviously there's TEE, which is a little bit more new to me personally. So everything that you can do on TEE in relation to Ethereum or even on BNB is going to be really exciting, especially for the data-owned economy and how we're going to start using data in relation to the things that we're doing on chain. There's lots of things.
That's pretty awesome. Nick, what do you think? And then what do you think are the benefits and limitations of the current solutions that are available for those developers?
Yeah, so first I want to say that I'm really glad that everyone is taking privacy seriously. Like even at ETH Denver now, you see this explosion of just this ethos of privacy. Like you have lots of zero knowledge, homomorphic encryption. Like these sorts of things were unheard of maybe like 1 or 2 ETH Denvers ago. So it's really heartening to see all of the developments going on in this space. So granted, all those technologies are great, and they have their own specific niche. What we offer at Oasis is trusted execution environments, which are basically like these special pieces of hardware that let you do your normal computation with your normal programming languages, with your normal semantics in this special hardware, and then you don't have to change anything. So whereas other things require you to adapt yourself to privacy, TEEs allow the privacy to adapt to you. Right? So I'm really excited about all the different methods we have adding privacy now to our dApps.
Awesome. Maybe Nick can talk a bit. I mean, I know I just talk about the Oasis Privacy Layer during the presentation, but from the technical perspective, can you walk through, how it works, for the audience? How does OPL, Oasis Privacy Layer, works for, Solidity developers?
Sure. All right. So I'm going to take an example. You're going to see this in a little bit, the live demo of this, but we'll do secret ballot. So the idea is you have like your DAO on BNB chain, and you don't want people to see what votes you're doing for like obvious reasons. So what you do is you deploy a ballot box on the Oasis Sapphire network, and you connect it to the DAO on BNB chain. So the user doesn't even need to know that Sapphire exists. They're just going to get privacy. So just keep that in mind. So now I navigate to the website. I hit the vote button. My wallet, MetaMask, pops up. It says submit a signed transaction, sign message. Not signed transaction, sign message. Now this message goes through the GAS3 layer. It goes through into Sapphire, and the vote is collected inside of this secret ballot box, and all that's protected and encrypted using TEE. At some point later, the ballot will be finished, like you'll meet the termination conditions, and then you want to actually effect that result on BNB chain, say like pay some people, do a DAO upgrade or something like that. So the message passing bridge is once again invoked without the user knowing that they're using Sapphire to bridge that termination message saying what proposal won back over to BNB chain, and then the rest of the process continues. So from the user's perspective, they head to the dApp, click the button, and then the rest of the day is fine. There's only one button click, and there's no real notion that you're doing anything special. It just happens to be private. So for developers, it's also very easy to integrate. So we try to make it super easy. So the dApp developer on BNB chain simply writes a couple of lines of code to like integrate it, and then maybe like a callback function to receive the vote result, and deploy the contract on Sapphire, and then they're good to go. But it's overall very easy to use, and I really hope that developers will find it as easy to use as I do.
Me too. Yeah, I wanna be able to try it out, because I think with private voting, this is like huge. It's super necessary. It's almost. I have a question really quick. Is it like I want to interpret if I had like a computer and TEE is like almost like the GPU to Ethereum is like the processor. So, what's relation to hardware? Do you think we can do?
Oh, so many things. Actually, it's funny that you mentioned GPU. There are new GPUs out that do confidentiality, so like they're GPU TEEs. So what I'm like super excited about here, let me get you started on Greenfield, man. Now imagine you have like your AI training data, like an AI models on Greenfield, stored using encryption, using confidentiality. So for those of you who don't know, Greenfield is Binance's new decentralized storage network. It's like IPFS plus. I'm like super excited about it. Anyway, so imagine you have your private training data that you contributed as a user, your private model, because of course, if you have the private data in the private model, it can leak data. So all that's encrypted, stored on on Greenfield, right? Now you have these GPU TEE, right? You load both of those things into the GPU TEE. That's controlled by the CPU TEE provided by on Oasis network. And then you have like the machine learning going on with auditability, integrity of blockchain, and the confidentiality of the TEE on the CPU and the GPU to do end-to-end secure machine learning on private data.
Right, and then you interface with smart contracts. So it's permission based. So the audibility that you want to add to your TEE, if I can actually enable private or audible functionality, I can actually do this. And if I want to encrypt it, I can. If I want to just say I'm gonna do a private vote, then you say, hey, contract, talk to this bucket. Everyone has to get inside of that bucket, like S3. So if you're familiar with like Amazon S3 and how data is kind of put into buckets, and then and then you put people inside of that bucket, we just call it groups. Everyone has an account. And then on this smart contract, you enable TEE. Before I run the ballot, then I just say, all right, make it public or make it private. If you're in that group, then good. And then we just still use Ethereum, which is great. Yeah, it's cool.
Yeah, it sounds really awesome. I'm really looking forward to have like more developers, on BNB chain using the TEE, using the Oasis Privacy Layer. So Dylan, as you're kind of at the forefront of BNB chain, like as we kind of like sitting here talking about privacy, do you see the demand? Obviously, you yourself see the demand, like while you're talking to your community developers, do you see the demand? Do you see the momentum where like developers start to care about adding privacy to their dApp?
So, yeah, yes and no. Like, I'll just be totally honest, is that we
love honesty.
Yeah. So I think we're looking for it. I think there's a huge need for the way that a network will eventually have some sort of regulation and some sort of decentralized network policy. And if they're going to require private functions to be on chain, then they're going to be looking for those applications. So it's like, I can't say if it's necessary or not right now, but I do know that it's important to learn how to build and try to see if you can apply it. And if you open source it, awesome, then we can try to plug it in. And DAOs, of course, who have new sorts of governance models, we're looking for more of these, and especially for the ones that are based on whether or not you're voting privately. Because the DAO might need to know whether or not your anonymity is there and secure, because that might be the promise of the DAO. And if the DAO has a lot of authority in terms of proof of authority, then it's probably absolutely necessary. It just really depends on what the DAO is signifying its holders, and that is going to come down to what everyone decides. So that I can't answer it all the way, but it's probably gonna have to happen.
Right. And then so it's not just like, if you think about Oasis Privacy Layer, it's not just for DAOs, right? We're also kind of like want to help more gaming projects so they can bring more game logic on chain. Currently, most of the stuff are off chain. So Dylan, like DAOs, gaming, those DID projects, like what can we do, to kind of like continue to educate privacy, bring this kind of awareness to them? What kind of tactics we can do to bring more people to start using, these privacy solutions?
Yeah. I wish I knew the full stack of like what it takes to be a game developer, because I've asked a few game developers in Web3 and they're just like, it's so hard to build a game in Web3. Like, it's hard enough to build a Web3 product and then building a game on top of that. So we're still, the infrastructure needs to be there, but I think BNB is really, it's super ready for enabling this, especially through NodeReal and a lot of the core partnerships that we have in working around with BNB. So I believe it's there. And then now it's about trying to figure out some of those solutions. And so it's really starting the conversation with a game dev who thinks like game, who wants to adopt gaming in this. And I'm more interested in knowing whether or not, if it's important that I'm trading in World of Warcraft, whether it's more important for me to trade in the terms of ducks and gooses with you, or if it's more important to not have my land be revealed. And then that's where we would use some sort of imagery in Greenfield. And I think there's just a lot of things that we can play with, but it's absolutely necessary. In order for me to run a game, I need CRUD. I need cloud. And so we have that available now on BNB. So now that we have our own cloud infrastructure, plus all the things that we have working in and around with BNB and the EVM compatibility, and hopefully with TEE, right? It's like mixing and matching all these things together is the same complexity of building a game. So it's, yeah, I think eventually a game developer who's going to be really smart and put all this stuff together that's coming for sure.
What do you think, Nick, as a tech lead and a tech evangelist for Oasis Network? Like, how can we help gaming developers, DAO developers, or even DeFi developers, to bring more privacy to their application that actually help improve their product experience?
Yeah, so I mean, like my day-to-day is just making things easier to use. So at Oasis, I always like to say extreme convenience, extreme convenience. Like we're trying to make it so easy for people to use that there's no reason not to use it. So part of the no reason not to use it is that there's no barrier to entry. Like these tools are available for you. You can choose what you need, what you don't need, and you can just drop them into your application, and it doesn't take that much thought. So like right now, it is extremely hard for game developers to make Web3 games, but like MetaMask comes in and like gives you their new Unity SDK, and that lowers that barrier to entry and increases the amount of adoption. So for privacy, we have to do the same thing. Like all the other domain-specific languages and whatnot for like coding up these like ZK circuits and stuff, like those are super cool pieces of tech. But as a developer, it's very challenging to learn these new languages and paradigms. Like these circuits are as different from like Solidity programming as like regular programming is to like writing FPGA code, if you've ever done that. So you have to think in a different way. So part of that is the extreme convenience is just making it accessible by giving developers the tools that they use and bringing privacy to them rather than forcing them to adapt to privacy.
The ease of use too. They're always asking like, oh, is it third web? Is there Dfinity? Like they want to use tools where they can just quickly deploy. Yeah, they're just looking.
Spot on, guys. Well, we can open up for Q&A if we have questions from the audience for the dev role, for Dylan from BNB, as well as Nick, the tech lead from Oasis. Okay, cool. I think we have. Okay, Will, you have the mic. Okay.
Hey y'all. So, question about Sapphire. I'm not completely familiar with how a trusted execution environment works and how it might be similar or different to like, I don't know, like Scroll's ZK EVM, but you were saying it's completely composable and you have all the features. So would that compare to like bytecode level equivalents for ZK EVM, or how would that look?
Yeah, good question. So ZK EVM, it turns the EVM code into a ZK circuit. So with trusted execution environments, you're running the exact same code as EVM. You're just doing it inside of a secure processor that nobody has access to. So it's like we literally took an EVM, ported it to run in an enclave, and it's like it's interpreted byte for byte.
If you could just explain the mechanism inside of this EVM in the enclave, I wouldn't understand. Like if you're in a private enclave and things are running there, it can access anything, and so there's no privacy inside. I can go. So, how do you? Just if you could explain the mechanism a little bit.
Yeah, so let's start from what an enclave does. So we use Intel SGX, which is one of the more popular hardware enclaves, and the SGX is a combination of a trusted TPM, which allows you to do remote attestation to prove to everyone else in the world that this is an enclave and it's running the right code. And then the CPU itself, and also the memory encryption engine, which makes sure that everything coming in and going out of the processor is encrypted. So within the enclave itself, like Intel SGX exposes a very narrow channel, so you can basically just post individual messages back and forth. So the main things going on when in an EVM inside of an enclave is the access to the MKVS, like the storage system. So first you load in, you pass the enclave requests the contract code. Then as the contract executes, like the bytecode, it will pull in more storage keys as the contract requests them. And then those are all doing the MKVS verification to make sure that's the right storage. And then it's decrypted within the enclave. And then the MAC tags are verified to make sure that the encrypted data still has integrity. So then once that's all done, the results are written back out to the MKVS, and then you can see any public side effects available to you on chain. Example through the block explorer.
Cool. We'll probably have time for one more question, and then we're going to head to the technical demo led by Nick. Any last question?
Hello.
Hello.
I actually have a question from the Oasis Network Discord. And some of the people are wondering if there's any drawbacks or caveats to using OPL. Like, for example, is it fast enough for gaming, considering that there's so many multiple components and network calls?
Really good question. So the cross-chain bridging, of course, takes a little while. You're going to see that in the demo. It takes maybe 30 seconds to get a message between chains. So for like real-time gaming, it's not a perfect fit. But for things where you can wait a little bit, like for instance, like revealing the data in an NFT or like unboxing, like those things are all fair game. And then if you wanted to actually have that real-time thing, like Opal is a spectrum. You can have all of your game on the layer 1 side and then bridge back and forth, or you can have more of your game on the Sapphire side, and then you can just submit transactions in real time and then only pay that 6-second block time.
Cool. I think this concludes our fireside chat. Thanks so much, Dylan. Thanks so much, Nick.
Thank you.
Really appreciate it.
Thanks, everyone.
Cool. And now we're going to do a technical demo led by Nick.
All right, hopefully you're not all bored of me yet. I have one more thing for you. So the HDMI cable was conspiring against me this morning, so I'm going to do the demo on someone else's laptop, and I guess that's a proof of generality. So I'm going to load up some Jigama. Okay. Yeah, I'm good. All right, so first we're going to open up the block explorer. So this demo is going to be secret ballot. I'm going to opl.pages.dev. All hail Cloudflare. All right, and I'm going to connect Linda's wallet. Linda, is this the right browser? Okay. All right, so in the meantime, I'll key you up for what's going to happen. So I have the OPL, and what you're going to see is secret ballot. So they're active proposal, inactive proposal. I'm going to go through. I'm going to create a new proposal. That's going to be on the BSC testnet DAO. And then what's going to happen is that proposal is going to be bridged over to Sapphire. Once that proposal is bridged, I can then tell the DAO that I have the ability to vote. And then once I do that, I can vote, and then the voting will close. This might take a little while because it's set up for anyway, I'm going to make a new poll, connect wallet, and I pray that Linda has already set up the BSC testnet. Linda, you can't run away right now. Pin. Can you connect to BSC testnet for me? Why is your MetaMask bugged? Let's refresh the page. That's so shitty. All right, guys, I'm gonna do it live. This probably won't work. All right, this is gonna be really weird. All right, so you can all see my laptop, right? All right, sick. All right, now we're gonna go to opl.pages.dev, and this time it's gonna work.
Guys, why don't we sit close to one another where Nick can do the demo via his laptop live. Let's sit close together. I know it's cold weather, so let's get cozy up. Use your mic.
I can do it. All right, so I'm already set up on the BNB testnet. So I'm gonna create a new poll. I'm gonna say like Sapphire. Is Sapphire good? And then the options are gonna be yes and no. All right, thanks. All right, so I'm going to submit that transaction to BSC testnet. Pretty soon, it's going to upload the data to web3.storage, and then it will shortly pop up a box saying submit transaction. All right, here we go. Let us submit that transaction. All right, so now we can see the transaction going into the BSC testnet DAO. So here's that DAO. And you can see my transaction 3 seconds ago just happened. All right, fantastic. So now what's going to happen is that this has invoked the seller message passing bridge. We use lots of different message passing bridges, but right now this one's seller. And now it's going to then pass that message over to Sapphire. You can see the Sapphire, the ballot box contract right here. And at some point later, the bridge will finish bridging. You can kind of see the progress right here. I need to restart this thing. This is a debug console for the bridge. You can see the internet's not amazing here, but like you can kind of see what's going on. All right, so you can see that's checking the block numbers, watching the contracts, all good. So this process, again, if you're a game, it might take a little while, but like it takes 30 seconds. I think it's pretty fast for most applications. OK, so we can see that the message is going through. The bridge is finished signing the message. It acknowledges it. Now it's going to pass it over to Sapphire. All right, transaction good. It's waiting to be mined. Fantastic. I think we're going well today. The technology may conspire against us, but we shall persevere. All right, so now this is the Sapphire testnet Explorer. You can see the messages. You can see the message coming through. So I think that this one's probably the recent one. Yeah, and then now we can go back to the ballot. We can go back to our secret ballot, and then our ballot has popped up. Internet's, of course, a little bit slow, but that's OK. I'm going to refresh the page. Internet is very slow, but that's still OK. So now this part I told you about earlier. I need to push the vote weight. So my voting token is, of course, on BSC testnet. Why move the voting token across? That's just a security risk to bridge those tokens and have that liquidity on the other network. So in this case, I need to push my vote weight. I've already pushed it in the past, so I don't need to do it again. Save some gas. And I'm going to vote. And the question is Sapphire good? And of course, I think it's good, so I'm going to say vote. So now this transaction is going to be sent to the Sapphire testnet. We have a gas relayer that allows you to just like never know that Sapphire exists. But for this demo, my MetaMask is a little bit weird on Firefox, so I'm just going to have to do it manually. And see, like, here's that error. Super bad. Oh, got to support Firefox, so otherwise you have the Chrome hegemony. All right, so switch network over to the Sapphire testnet. I'm going to vote. OK, so now at this point, the vote will be sent to Sapphire testnet with confidentiality. I'm going to show you how we can see that it's being encrypted. I mean, you probably can't see it from where you're sitting, but like we'll try anyway. OK, so at this point, the transaction has been submitted, and we're going to go to Sapphire testnet Explorer. This is the ballot box. And refresh the page. OK, here's our transaction. It just popped up. All right, so now we're going to go look into this transaction. So on normal Ethereum transactions, you have the data of the contract. It's just plain text. You can decode it, and it's all public. So we're going to see what happens when you so what this contains actually is a bunch of encrypted data. If we poke this into the Seaboard decoder, you paste in, you see a bunch of encrypted messages instead. This is CyberChef. I need to do hex decode as well. So right now, we're just waiting for the bridge to do its thing. It's going to come back. The voting is closed. OK, from hex, excuse me. OK, so here we have inside of the Ethereum transaction data, we've done some clever trickery to pack the encrypted data in a way that's compatible with Ethereum tooling. So in the hex data, you have actually this whole Seaboard encoded struct that contains the data, the public key, the non-C, and all that other stuff to be decrypted by the Sapphire paradigm. But that's all just an implementation detail. I just want to show you guys that it's actually private. All right, then we head back to the secret ballot, and the bridge has done the thing. It's bridged it back. And now we can go see that our vote has now under pass proposals, meaning that it has closed. So in this case, you can actually see my vote because I actually enabled the see votes after voting has completed. But in this case, yeah. But otherwise, if you didn't enable that while voting is going on, you can't see it. So this is actually completely protected. Now, if I had more screen space, I would show you how easy it is to add. But like, literally, the whole ballot box plus DAO contract took maybe 50 lines of code, and only 20 of those at most were due to Opal and not just the innate complexity of ballots. All right, so the internet is like pretty bad, but you guys get the idea. So thank you for watching this demo, and I'm happy to answer any questions offline or yeah, well, once I'm done. But thank you.